Good morning or afternoon. It's morning for me. I'm making this video. It's Unit 1, Video 4, Complex Numbers. Hopefully by now you got a rhythm with what we're doing. So here we go. This is the assignment. So it kind of, here, let's scroll. There we go. 24 questions that I'd like you to work through. And then there's an answer key, of course. But down at the bottom it says, use quadratic formula to solve. That's basically where we're headed. So it's at the very bottom. But here you go. Here's the answer key for all this stuff. You'll notice on number 22 and number 23, I say careful, these reduce. So for number 22, it says this one reduces, not 34 plus 2i over 40. Because if you notice that answer right there, 2 goes into all of those numbers, so it can reduce. You can reduce these kind of numbers. Watch out for that, because sometimes you'll check your answer and it won't match with mine. There's a couple things that you might have done incorrectly to have that result. But here we go. We're going to talk about something called the number I. Now, what I want to do is I want to start with where we're going to see the most of this is like question 23 and 24 on this assignment, where I give you something like this, and I say something like x squared minus 2x plus 6 equals 0, right? That's a quadratic equation. I want to solve it. I know I have two answers, and this is very convenient to plug into the quadratic formula. I have an a value of 1, I have a b value of -2, and a c value of 6. And hopefully quadratic formula is burned into your brain by now. But if it is not, let's see. There we go. That is what I'm going to use. So I would say negative b, since b is already negative, I'd say 2, plus or minus square root of b squared. -2 squared is 4, minus 4ac all over 2a, so 2 times 1. And here's what happens. In this particular situation, I have 4 take away 24. Well, 4 take away 24 is -20. So up to this point in your entire math career, we have told you to quit working because you can't take the square root of a negative number. That's not true. We just did not teach you about the complex number system yet. So that's what you're going to learn about today. However, the state of California wants me to teach you the basics, which are: how do you simplify complex numbers? How do you add and subtract them? How do you multiply and divide them? That's what the state of California wants me to show you. And I will do that because I work for the state of California. However, where is this going to pop up for us in our immediate future? Right here. This is where it's going to affect us. What happens when we do get an answer like this? Well, you still have to know how to simplify and everything to get this done. So let's begin talking about simplification and what are I numbers all about anyway. So here we go. If I have the square root of 4, well, guess what? You take the square root of 4, you get 2 for an answer. Everyone knows that. You take the square root of 9, and you say, what times itself is 9? You go, oh, that's 3, right? But when you stick a negative on either of these guys, what's the square root of -4? We now call this answer 2i. What if there is a negative on there? We call that answer 3i. Oh man, what if it's not a perfect square like this guy? What if it's one of these dudes? Well, here's the thing. Every single number that is negative could be written like this. It could be written like -1 times that number. It could be. And then you say, well, that means I have technically the square root of negative 1 times the square root of 20. That is true. That is what you have. So here is what the square root of negative 1 is equal to. The square root of negative 1 is called I. It is a definition. In mathematics, there are some things that are definitions or postulates or theorems or whatever. A definition is something, hey, this is what we have come up with. Live it, love it, know it, use it. So I is called the square root of negative 1. I stands for the word imaginary. It's called an imaginary number. So when we see a negative under the radical, we say, wait a minute, that means there is an I value in this answer, an imaginary number value. It represents square root of negative 1, but we never write that. We just write I. So what do I do with this 20? Well, I split it up like I always do. I say that's the same as 4 times 5, which means I have 2 come out. I have rad 5 stay home, and then I just stick that I right there, and that's the answer for this. I know you're going, what? Well, here we go. Complex number system. Let's talk about it. In a lot of the books, including our book, they refer to it as A plus BI form. So, complex numbers are two-part numbers. This is called the real part, and this part over here, because it has the I, is called the imaginary part. Now, I am never going to ask you for this. I am not going to say, what is the real part? What is the imaginary part? Because it's a very basic question, and it's a boring question. If I gave you 7 plus 3i and I said, what is the real part? You would say 7. If I said, what's the imaginary part? You'd say the 3i part is the imaginary part. And I'd say, very good, you're correct. Here's the thing. All books stress this because when you go farther in math, you will find that imaginary numbers or complex numbers can streamline a lot of mathematics. They can. But you're in Algebra 2, so guess what? I teach you the basics, how to simplify, add, subtract, multiply, divide. That's what I teach you. But this guy right here, all the math books are like, you better write it in this format, because if you don't, you're going to be in trouble. They do that because they know what's coming in your future. Think of it this way. Complex numbers are two-part numbers. They have a real part and an imaginary part. But let's suppose you get an answer. You're working with something and you get, I got 4 for an answer. You do not have to write 4 plus 0i. You don't. Let's suppose you're working on a problem and you get 9i for an answer. You do not have to write 0 plus 9i. I don't care. The only reason you would care is in your future, they want you to know that there are 2 parts to every complex number. So that being said, let's just talk about simplifying. We did a little bit of it up here. We did. So, let's play. Let's suppose they gave me something like this, and they said, what is the square root of negative 32? Well, here's the rule with this. If you see a negative under the radical, you immediately poke out your eyes. You're going to have an eye pop out. That's going to be in your answer. The first rule of complex number simplification is radical with a negative means your eye is going to pop out of that radical. Now, what do you do with the numbers? Same thing you did before. You go, hey, 32. The largest perfect square that lives inside of you is 16, so I can say 16 times 2, which means if I take the root of that, I get a 4. So I have 4i on the outside, I have rad 2 left on the inside. That would be simplified. What if they gave me something like this? 5 rad negative 40. And I go, okay, there's a number outside. Well, that's okay. I'm going to poke out my eyes. I'm going to say 40 is just 4 times 10. That means I can pull out a 2. So I have a 2i coming outside, but I already had a 5. What do I do with all that stuff? I multiply. So I go 2 times 5 times I is a fancy way to say 10i. What's left over on the inside? Rad 10. That is the simplified version of that number. So simplifying this, if you know how to simplify a radical, hey, that was in your summer packet. If you know how to simplify a radical, then you can simplify these numbers. Let's suppose they give you something like this. What if they gave you 3i, let's be tricky, 3i rad negative 4. So this guy right here pokes out an I. This guy right here, square root of 4 is 2. So this turns out to be, I have a 3i on the outside, I have a 2i. That's what this part turns out to be. So that means I have 2 times 3, well, that's 6, and then I have I times I, that's I squared. Wait a minute. Here's the tricky part. You look this answer up on my answer key, and it does not say 6i squared at all. It says negative 6. Now, it does not say negative 6 plus 0i, which makes me always say negative 6 plus oi. But I just wrote the answer as negative 6 on the answer key. Well, why did I do that? Well, you guys know this rule in math. If you take a radical, whatever it is, rad 5 times rad 5, that's the same as rad 25. But we take a shortcut. We all like shortcuts in math. We go, oh, well, that's just 5. What if it was rad 15 times rad 15? We just say, oh, shortcut, that's 15. So if I took the square root of negative 1 times the square root of negative 1, I would get negative 1, because we all enjoy shortcuts. But guess what? That's the same thing as I times I, which is I squared. So whenever you see an I squared in your problem, it is the same as a negative 1. So instead of 6i squared, I call it 6 times negative 1, or I call it negative 6. There you go. Now, there's more to I numbers. There's a lot of stuff, but like I said, we're going to hit the basics. That's what we're talking about right now. So we're going to focus on the stuff that we need for our future. Let's continue a little bit. So I'm going to give myself some room here. And what if they gave me something like this? 5 rad negative 3 times 2 rad negative 6. Well, I do not want to multiply negative 3 times negative 6 and call it 18. I'm going to get a sign error on my answer. Here's the deal with this. If you see a negative under the radical, that means you automatically poke out your i's. Even though you can't take anything out for rad 3, you take out the I. So I would rewrite this as 5i rad 3. Similarly, I'm going to poke out my i's over here. I'm going to say 2i rad 6. Now I can actually multiply and get this thing cleaned up. On the outside, I would get 5 times 2. Well, that's just 10. I'd get I times I, that's I squared. I would get rad 3 times rad 6, that is rad 18. But now we still have to clean this up. Simplifying still means I can't have an I squared in my answer. If I see I squared in an answer, I know it's wrong, because I squared represents negative 1. So what do I really have on the outside? I have 10 times negative 1, we'd call that negative 10. But I'm still not done, because I see radical 18. And I say, well, rad 18. 9 times 2. 9's the perfect square that lives inside of that, so I'm going to pull out the 3. And I am going to say, hey, that's negative 30 rad 2. And that would be the simplified version of this original question. So what we've been talking about is simplifying stuff. You're going to run into different practice problems. I made up some practice problems for you to try. But let's move on to some adding and subtracting stuff. And let's go take a look at what we're up against. I'm going to scroll back up for a little bit. Okay. So it says here, evaluate each. Those are the type of problems I just did with you guys. But you'll see in the add subtract section, like the very first one, number 8 there, it has a look like this, like 7 plus I minus 4 plus 5I. That's what it looks like, number 8. So here's the rule for adding and subtracting. Real parts go together. So I go 7 take away 4, that's 3. I parts go together. So I have an I plus 5I, that's 6I. I write it in A plus BI form, because that's what they usually ask me for. So that's my answer. 3 plus 6I. I am done. When you add or subtract complex numbers, it's basically combining like terms. I know you know what that means. Combine like terms. So what if they give me something like number 9, where they're trying to mess with my mind? They're going to give me something like negative 3I plus 6 minus 2I. Well, why did they put that in parentheses? They don't need to. See, sometimes parentheses are necessary. Sometimes parentheses are overkill. This is a section of the book where you'll see some problems where, why did they put parentheses on all these numbers? Here's the reason. Technically, A plus BI form, that is one number. So customarily in the books, they put these in parentheses to represent, here is a number over here, you're going to add it with this other number. But you know what? There's nothing outside those parentheses. You're adding stuff, so you can simply ignore them. And then you go, hey, there's nothing to combine with this guy, so it's 6. These two pieces go together because I'm going to combine like terms, so my answer is 6 minus 5I. Adding and subtracting. So once again, let me show you this. What if they gave me 4 plus I minus 7 plus 3I? Now, you'll see, they want me to think of this as one number. They want me to think of this as one number. But parentheses do not change the meaning of this number here. But since there's a negative out front, this guy is now going to be affected. So when you're adding and subtracting these problems, keep in mind, take a look at the ones I made up for you guys to practice. Sometimes the parentheses are necessary. They will affect a change in the problem. Sometimes they are not necessary, and they won't change the problem. So here we go. How would this affect me? Well, I would distribute the negative. That's it. Here, I would say 4 plus I do not need the parentheses. But in my next statement, it would be negative 7 minus 3I. Combine like terms. These guys go together. I got negative 3. The other two guys go together. I get minus 2I. There's my answer. I am done. So adding and subtracting, that's what you do. Now, what if they start me out with something that needs to be cleaned up a little bit? Well, because they'll do this to me sometimes. Maybe they'll go 4 plus the square root of negative 25 minus 8 times the square root of negative 49 minus 3, something like that. Well, I would say, hey, I got to clean this up first. Square root of negative 25 is 5I. The square root of this is 7I, but I got an 8 outside, so I go 8 times 7, well, that's negative 56I. I didn't do anything with these guys yet, but I'm about to. They're regular numbers. I'm going to combine them. So I'd get 1 and then combine like terms. What are these guys together? Negative 51I. There's my answer. So they can do stuff like that to me to make it a little bit sneakier. Now, since I'm right here, see those multiply problems? Guess what? When you multiply I numbers, they are two-part numbers. They put them in parentheses a lot. Well, when you see a parenthesis next to another parenthesis, guess what? You do something called foiling. So let's FOIL some of this stuff. I'm going to give myself a little room, so I'm going to go down here. And you can see my answer key is poking its head there. So let's talk about multiplying, because this is actually not that bad. Here we go. Let's try an example for multiplying. I'm going to do 4 plus 2i times 5 plus 3i. FOIL it. First times first, so I get 20. First outer, I get 12i. Inner, plus 10i. Last. Now here's where I'm just telling you, write it out. Don't struggle. Don't make your brain work harder. Sometimes people try to avoid work by not showing it because I could do that in my head. And that's when people start making goofy little sign errors. Look at that guy. Positive 6i squared is the same thing as 6 times negative 1. So this guy is just negative 6. So I go 20 take away 6 because those are combinable. That's 14. 12i and 10i, that is 22i. And you have multiplied two complex numbers together. Hallelujah. Let's try this one over here. What if they gave me negative 1 plus 2i and 3 minus 4i, something like that. Ooh, 4 eyes. That's what they call me in school because I wear glasses. Anyway, here we go. I'm going to first outer, inner, last. That's what I'm going to do. So I'm going to say negative 1 times 3, that's negative 3. Negative 1 times negative 4i. No sign errors for me, please. And then, what is that? 6i. And then positive times a negative is a negative. 8i squared. So I go, wait a minute, that's the same as plus 8. Huh? Because negative 1, huh? So here we go. A negative 3 plus 8, that's a 5. 4i and 6i is 10i. And there we go. Multiplying is not a big trick. It's not super gnar. So here we go. See the multiply problems I made up? See number 16, guess what? You'd have to take rad negative 9 and do something to it before you can actually multiply. Let's talk about division. Let's talk about dividing these numbers. Because there's two types of problem there. Problem numbers 17, 18, 19, 20, those are monomials. Monomials. There is only one term in the top, one term in the bottom. Monomials. But number 21 and 22, there's more than that there. Those are binomials. So, I'm going to do division down below. Got to get some room. Going to bypass all this stuff we did already. I'm going to talk about dividing complex numbers. So we go division of complex numbers. There are two types. Let's talk about monomials. So monomial division looks like these, like my examples up there, or my practice problems like 4 divided by 3i. Okay, here's the rule with this. Since I represents the square root of negative 1, you cannot leave rads in the bottom. It's just like it was in geometry. I don't know if you guys remember this. Sidebar for a second. They made you do stuff like the sine of theta. The sine of theta equals 2 over rad 3. And then you were like, oh, I can't leave the rad in the bottom. So you'd have to rationalize it, and you'd have to multiply it out and say, oh, 2 rad 3 over 3. You could make it pretty. You could make it polite. Well, in mathematics, we try to follow the same rule. Once it's made, we follow it. So here's the thing. We do not write this like this. It looks weird. We never write this. That's what I represents, but we don't write it that way. But there is a way to get rid of that. It's based on the same concept here. It's based on the same concept. If I multiply top and bottom by rad negative 1, I get that out of the bottom. But we just do it this way. Look. Times I times I. Watch. I get 4i on the top. On the bottom, I get 3i squared, but remember, I squared is -1, so I just call this -3. Wait a minute. If you look at my answers on the answer key, I did this to you, just to get you used to it. I wrote my answer like this. They're the same answer. They are the same exact thing. Some people get hung up. They go, well, wait, I got a negative on the bottom. How come the negative jumped to the top? Or how come the negative, let's do this one. How come the negative jumped to the middle? It didn't. If you have a positive thing divided by a negative thing, it is a negative quantity. So you can denote that by putting the negative either in the top, the bottom, or the middle. It doesn't matter. Just don't put it on the top and the bottom, because if you do, then the negatives cancel. It becomes positive. So get used to that. When I do, division of complex numbers, I don't want to lose where I'm at. With a monomial, something like this. How about 6 over 2i? Well, I say can't have an I in the bottom, so I multiply top and bottom by I. That gives me 6i in the top. That gives me 2i squared in the bottom. 2i squared is a fancy way to say -2. Now, wait a minute. Doesn't 2 go into 6? Sure does, so I can reduce this. So I would say 3i, but I would not say 3i over -1. Look at how cumbersome that looks. What would I just say? I would say minus 3i. That's what I would say, because it's more compact. Now, could I say 0 minus 3i and be like our book? Yes, I could. Which, by the way, I don't know if you've noticed this, I have put every single practice problem on these videos. I have not used the book yet. Doesn't mean I won't, it's just I want to make sure our first unit runs extremely smooth, meaning all of the assignments are embedded. I would embed them anyway, but I want to make sure whether or not you got a book, maybe you transferred into the district. I don't know what your story is, but I want to make sure that you can stay current and do all the work with us. So all of the practice problems, hey, they're in the lesson, but this is how that answer would be written in our book. This is just fine by me. That's totally a fine answer right there. Okay? Totally fine. Okay. Well, what if they gave me something like this one? Because they did. 5 over, and then they gave me something like rad -8. And I go, whoa, you can't have a rad -8 in the bottom. But I also know I am supposed to poke my eyes out first. Now, I could simplify rad 8 also. I'll show you what I'm going to do. I'm just going to do this. I am going to say I rad 8 times itself. If I multiply the top and the bottom of any fraction by the exact same thing, I am not changing it. So what happens in the top? I get 5i. Rad 8. On the bottom, I got I times I, so that's I squared. That means negative. Rad 8 times rad 8 is 8, so I'm going to call that -8. But then I go, wait a minute, that's not the answer that he has in the key. That's because I still had to simplify rad 8. It's 4 times 2, so I can kick out a 2. So what happens is I have 10i rad 2 over -8, and then I can say this number and this number are both external. So 2 goes into both of them. 2 goes into the top. I'm going to scroll down. 2 goes into the top 5 times. So I have 5i rad 2. 2 goes into the bottom 4 times. So I have a 4 in the bottom. But you know what? I'm going to get into this habit. I'm going to just stick the negative on the top. Get into that habit. When we get to rationals, when we get down a couple units from here, it's a good habit to be into. Put the negative on the top. Okay, so what have we done? We've done monomial division. Let's do binomial division. We haven't done that yet, and then we're almost done. So let's talk about binomial division. because binomial division looks different. If I gave you something like complex number 2 plus 3i, and I'm going to divide that by 5 minus 2i. Okay, first off, I don't get to reduce stuff. Please do not do this to me. Ha 2, there, I could do that. Let's get rid of that. No, you're making up your own rules. Don't do that. Ouch, I'm going to take all of that away. Here's what we do instead. See, this is a binomial. This is one number. This is one number. They do not match exactly. I don't get to reduce them. I don't get to do any canceling. But here's the thing. I can't just multiply the bottom part by I and multiply the top part by I. I can't do that. If I did, look, if I multiply this guy in, I would get 5i minus 2i squared. Then I'd say, hey, that's just the same thing as 2, so 5i plus 2. And I go, wait, I still have an I in the bottom. See, it doesn't work. I can't do it that way. So when it comes to binomials, this is why I kept this idea separate. Boom, I'm taking all this stuff away. Take it away now. The only way to get rid of it is by using something called the conjugate. And I don't care if you memorize the name conjugate, but I do want you to know what it is when you recognize it. So here it is. The exact same numbers, but you change the sign in the middle. Oh my God, how did I mess that up? So if I multiply the top and bottom by the exact same thing, I'm not really changing it, but what you'll see is I am now going to have to do the FOIL again. I'm going to have to FOIL this stuff. So in the bottom, you're going to notice a shortcut happen to you every time. First times first, I get 25. So I go first times first. Outsides, I get 10i. Whoop, 10i. And then minus 10i. What? And then I get minus 4i squared. That's the same as plus 4. What happens is these guys will always cancel. If you use the conjugate, you will get all the I values to drop out in the bottom. What do I end up with in the bottom? 29, it looks like. I get 29 for an answer. Well, what's the top part look like? I don't know. Let's FOIL it. Now, I'm not doing 2 plus 3i times its conjugate. So I have to actually go through the motions and figure out what's going to happen here. So in the numerator of this thing, I'm going to get 2 times 5, that's 10. I'm going to get 2 times 2i, that's 4i. I'm going to get a 15i. And I'm going to get positive 6i squared, which is fancy talk for minus 6. 10 take away 6 is 4. 4i and 15i is 19i. And that is my answer. So take a look. I'm going to scroll up real fast and then scroll back down. In the division section of this practice sheet, I made up 2 problems. Because once you get the idea, you got the idea. Number 21 and number 22, there you will find, here, look at 22. There's my answer. This is what you're going to get when you do 22, if you do it correctly. But I want to explain to you how to reduce things. 34 plus 2i over 40. It only happens if all 3 values, all of them, have a common factor. You get to reduce it. What goes into 34, 2, and 40? The number 2 goes into all those, therefore it's reducible. Okay? Don't be tricked, though. Sometimes you see something like this. Hey, I did the math, and I got this for an answer. And you go, I'm going to reduce it. Well, I know that 3 goes into 15, 5 goes into 15, but 3 does not go into 5. These guys don't all have the same common factor except for 1, and if 1 is your only common factor, you don't get to reduce. That is simplest form for that answer. You can't reduce it. Now, something like this, though, if I had 5 minus 10i over 15, now that's reducible. That's totally reducible. Look at that one. What goes into all those guys? 5. Then I could reduce. That's how you reduce complex numbers if you see that happen to you. You're going to see that happen to you sometimes when you do division. So let's do another division example. How about 1 minus 2i divided by 7 minus 3i? And I say to myself, hey, I'm going to multiply by the conjugate of the bottom. Not the conjugate of the top, conjugate of the bottom. In the bottom, if I FOIL it, I am going to get 49 plus 21i minus 21i minus 9i squared. That is plus 9. So boom, boom, those are gone. 49 and 9 gives me 58. That's what I get in the bottom. Then, in the top, we got to FOIL it. So in the numerator, if I FOIL it, I get 7 plus 3i, right? I get 7 plus 3i. Then I'm going to do this and this. So I'm going to get negative 14i minus 6i squared. That's fancy talk for plus 6. So 7 and 6 is 13. 3i take away 14i is negative 11i. And I don't think there's anything, since 11 and 13 are prime, that goes into all of those guys. So this guy will not reduce. He will not reduce. And that's okay. Not everything has to reduce. Okay, we're almost done with this lesson, but there's one thing I definitely want to make sure you know. I have purposely avoided doing anything that totally, without a doubt, requires a graphing calculator up to this point, in case you don't own one. Remember, I said at the in my video, the very first video I wanted you to watch was the graphing calculator. So a TI-84 doesn't have to be bells and whistles fancy. Those are nice calculators. TI-83 doesn't have to be bells and whistles fancy. Those are, those are the two that are very similar to each other. And in fact, when I do have to use these calculators in my lessons, I will interchange between the two. So in case you have one of these, you'll see what makes it subtly different from this one, okay? And vice versa. But once you get the hang of your graphing calculator, the skies are the limit. You can do a whole lot of stuff with them. But we will still not need them this week. But we will need them definitely starting our next unit. Or, sorry, not our next unit. We'll need them next week to finish this unit. So anyway, here's why I'm mentioning this right now. Some people find this fancy trick on these that helps you do complex numbers. It helps you do I numbers. But I warn you, I know this also, and sometimes the answers you get on the calculator are not going to match the answers you'll see, because the calculator doesn't know how to reduce things sometimes correctly. And it does not know how to simplify radicals. So let me remind you, how did I start this lesson? Let's go back up here. I started this lesson by saying, what are you guys going to need to really use from this lesson? It's going to be this stuff. When I ask you to solve something with a quadratic formula and you get this kind of answer that I have circled here, well, guess what? That answer is not simplified. This is something your calculator cannot do for you. So you do have to understand complex numbers. So don't hope you're going to get a shortcut out of this. So let's talk about it. I'm going to finish this part up right here in red. So see here, I could poke out my eye. See here, I could branch this off and say that's 4 times 5. If I do, I can pull out a 2. So this answer becomes 2 plus or minus 2i rad 5 over 2. Now wait a minute. There are 1, 2, three numbers here that are all external, and they all have a common factor of 2. So 2 goes into this once, 2 goes into that once, 2 goes into that once. So my final, completely cleaned up, simplified answer would be 1 plus or minus I rad 5. So guess what? When you guys get to the bottom of my worksheet here, I'm going to ask you to do 2 quadratic problems for me. Solve using the quad formula. Solve using the quad formula. Okay? Your calculator's not going to do this correctly. You've got to know how to do it. So you'll notice, number 23, it says reduces. Number 24, it does not reduce. Some things reduce, some things don't. Alrighty, guys, that's the end of this lesson. Please practice your skills with complex numbers. Okay. Hasta luego.